Hi everyone, I'm Daniel Bogdanoff, and today is Friday, March 15th, which is both a great day and it's also a little bit sad for us all, and I'm sure you feel the same way because today's the last day of Wave. But we still have a bunch of prizes. Today we're giving away a 1000X, two handheld DMMs, a couple probe packs, and the grand prize, a 6 gigahertz 6000X series oscilloscope, and an ESOF ADS license. Both of those clock in at like 20 or 30K in the US, and so they're some of the biggest prizes we have ever given away. If you signed up at wave.keysight.com or wavekeysight.com, both of them work, you are in these drawings. So we'll draw them later at the end of the stream. And after that, the giveaway will be over.
What kind of car does an electrical engineer drive?
The party doesn't have to end. We're here year-round.
A Volkswagen.
You just can't get rid of us. I suppose you could ignore us, but
2 antennas got
stuck.
married.
We're not going anywhere.
The wedding was lousy,
This YouTube
but the
channel will have
reception
new
was
videos every other week or so on Tuesday mornings at 10 a.m. Mountain Time.
A superconductor walks into a bar.
So make sure you are subscribed to the Keysight
The bartender
Labs
says,
YouTube
"Get
channel.
out. We don't serve
Hit the
your
little
kind
bell
here."
so you know when
The
those videos
superconductor
come out.
left
You get push notifications.
resistance.
Go do it. I'll give you a second. If you don't push the bell, you don't always get notified. YouTube does funny things with the algorithm. We also have a lot more going on than just the videos. We're going to keep podcasting over on the
Why did the power transistor spouse
over on the Keysight
take away the
Podcast
TV
YouTube
remote?
channel, or your favorite podcast delivery
It wouldn't
engine.
stop switching.
A little bit about that podcast. It's inspired by the hallway conversations that we get to overhear in the building.
Watch me.
We pull in guests from the building and from outside of Keysight to talk about the
Why was
next and
MC
upcoming
Escher
trends in
fired
electrical
from his
engineering
electrical
technology.
design job?
One of the nuances
He was
of new
intentionally
technologies
building
that
in
come
ground
out
loops.
is that they all have to be tested. So groups like the PCIe SIG and
What
JEDEC
do you
and the
call
MIPI
a
Alliance,
detective
they all
electrical
pull us into these
engineer?
planning
What?
processes really
Sherlock
early in their
Holmes.
development cycles because they want to be able to test
pretty
and
good.
debug, for example, like their PCIe
Why
Gen
was the
5 device
inductor-
or their next 5G design before they ship it out to the world and hope it works. So we as Keysight have to be ready for those technologies really, really early on in the stages. So the podcast is a great way for you to get the inside scoop on those technologies from an engineer's perspective instead of the high-level news pieces that you'll see on some other places. The blog is another great place for that. You can check it out over at blogs.keysight.com. So if we pop over to my laptop here, I'm going to pull off the countdown timer. If we can pop up to the laptop. If that doesn't work, oh look, there's the joke video. Hopefully that's not still playing audio. I kind of bet it is, huh? So I apologize to everybody. There we go, much better. So if you were getting some jokes in there, you're welcome. So if you go to blogs.keysight.com, you can see we have a ton of new blogs coming out all the time. For example, here's a blog on PCIe 5.0. So if you want to keep up with us and keep up with new trends in the technology, check out that website. It's awesome. You can also find us on Facebook and Twitter if you're into those things. There's always a lot going on. Links for those are in the description. If they're not now, because I don't think I put them there last night, they'll be there at the end of the stream. If you want to keep learning, we'll keep creating. We also have some new schematic challenge questions coming out on the Facebook page in the coming weeks. So if you like Facebook and you're on Facebook, check out the Keysight Bench Facebook page. It's also a good way to keep up with any future contests or sweepstakes that we run. For example, we have a huge student IoT design contest coming up in April. Let's pop back over to my laptop and take a look at that. If you go to IoT Contest, Keysight.com, you'll land on this page. And we're going to play a quick little promo of that video that the team has put together. We are really excited about this contest.
The world is getting smaller. So is technology. We're in an age of engineering marvels. Yet the world needs more great ideas. Because by 2050, our planet will change in unimaginable ways. 2/3 of the world's population will live in urban cities, exposed to unhealthy conditions in their daily lives. Over 5 billion people will suffer from water stress. We need innovators, developers who think big and small. Ones who imagine how crowded cities can be more livable with smart sensors. Ones who wonder how to intelligently monitor our waterways to ensure clean water. Will you be that innovator? One global competition for engineering students like you. To power ideas for a smarter world through the Internet of Things. Your IoT innovation, Keysight support. Up to $50,000 in cash prizes, university lab equipment, and an all-expenses-paid trip to the final competition at the 2019 World Maker Faire in New York. It's your chance to make the world better for billions. Want to be part of the solution? The competition opens April 2019. Now is your time. Seize the opportunity and join us in changing the world.
So on this page, let's go back to the laptop here. On this page, if you scroll down to the bottom, you can actually get notifications for when that contest goes live. Again, we are really excited about that. And my understanding is, and I don't know 100%, but I think some early registrants might also get a gift of some type. But don't hold me to that. I don't know 100%. It's a different team working on that, but it might be a DMM, just saying. So you should go check out the IoT contest. And again, the prizes for that are huge. And the final contest is at the Maker Faire in New York City. So it's a really cool opportunity for you, especially if you're a student. I know some of you said you were students earlier in one of the videos. So a quick side note, I apologize earlier for the joke video running in the background. If you've been with us on the other live streams, that was kind of our pre-roll. Our video professional actually is out sick. So we've been a little scrappy this week. It's kind of like scope month from back in the day if you've been with us for a while. So it's a little nostalgic, but thank you for bearing with us through that. And now let's jump to today's tip, where we're going to look at a creative way to use your scope's memory. We've talked about segmented memory before, but I thought we'd put a new twist on it this year. You've probably seen it with this RF chirp pulse. But today we're also going to look at a protocol bus. So let's start with chirp pulse. I'm going to keep the camera wide just because I think you can see this well enough on the wide camera. One of the challenges, if you look at this RF chirp, there's a signal going, it's a little burst, and then the line is just dead for a while. And there's a bunch of these pulses. And the problem is, if you try to capture this amount of memory and zoom in, all of a sudden, you're going to start losing resolution. So you hit run, and say you want to capture, 100 of these pulses, and you want to characterize your chirp pulse. If you stop it and zoom in, all of a sudden your signal looks really bad. What's happening is you're running out of memory, and the ADC basically has to digitize down and capture less data. And this is going to happen on any scope, regardless of your memory depth. If you want to capture a lot of signal detail, it's just going to be a problem. So this is what happens if you're zoomed way out and you don't have enough memory. This is what it should look like. So the other thing, there are situations where having longer memory will help. But let's look at an example on the 3000T. We gave away a few of these. If you look at the screen here, you can see we have a protocol bus going. There's a lister. It's decoding. If I zoom out a little bit, you can see all of my different packets here. And we have an error. If you have an error on your bus, and I know it's a little washed out on the lister, so I'm just going to hide that. It's always hard to capture these screens properly with a camera. If you're getting an error like that, it's a really common debugging tool to want to capture all those errors and figure out what else is going on. So often the errors aren't very close together, so you're going to need more memory. Again, you're going to run out of memory at some point with any scope. So what you can do is turn on segmented memory. Right now, we're triggering on this error. That's why it looks static on the screen. So if you go into Acquire on these InfiniVision scopes, and right now we're in normal acquisition mode, which is great. There's a blog and some articles, and I think even a video on the different types of acquisition modes. It's like averaging peak to text and some of those. We're not going to look at those today. We're doing QA at the end, so if you want me to go through those later, I'm happy to. If you go into segmented, right now we're set up to capture 60 of these captures. So I'm going to start this up, and we're going to start capturing. You can see down here as it's counting up. These are each a trigger event, and it's taking a while because these signals, these errors that we're trying to trigger on are really, really far apart. So it's going to take a few seconds. It's not because the scope is slow. It's because it's capturing seconds and seconds of data. So essentially what we've done is you can even scroll through this and look at different packets, and these all look pretty similar because it's the same error packet. So if you were to see this, this would be a good indication of probably a memory controller error or something like that. We've captured, if you look at the time tags, I'm going to scroll all the way down to 60 here. We've captured 17 seconds worth of data. And all we've captured, though, is just this packet of data around the error. So if you're trying to characterize errors on a scope, this is, segmented memory is something you just absolutely almost have to have. Because nowhere else are you going to be able to capture 17 seconds of data at full memory depth. So segmented memory comes in handy when you need to capture a longer span of data. We can talk more about that in the QA. We're doing that at the end. Aaron's going to come out also. You can put those questions in the chat. Now it's time for the giveaway. So again, we're giving away a 1000x scope, a couple probe packs, a couple handheld DMMs, and I'm going to pull up the winners for the day. This is the last giveaway of Wave 2019. So the scope is going to go, the 1000x 200 megahertz scope, I think it comes with all the options and a bench view license too, is Jaroslaw Suzuki. Congratulations, Jaroslaw. We'll be in touch with all of these winners within 72 hours or so, business days. The handheld DMM winners go to Bernard Sturzbach and Daniel Klemenko. Congratulations to Bernard and Daniel. You win the U1233A handheld DMMs. The probe packs go to Keith Bandrowski and Mohammed Awakal. Congratulations to both of you. The bench view license goes to John Williams. I really hope you are the Star Wars music composer, but I doubt it. And then the two grand prizes, the ESOF ADS license and the 6000X series scope. The 6 gigahertz scope goes to Jeremy Brookley, and the ESOF ADS license goes to Robert Arp. Congratulations to our winners. And thank you to everyone. This has been the biggest, most attended Wave/Scope Month event that we've ever done. It's been running 4 years, and we've just been overwhelmed and blown away by you guys. It's been a really, really great event. Thank you so much for being an awesome audience, an awesome support base for Keysight. And now we're going to move into some Q&A. So put your questions in chat, and Aaron's going to come out. We have a couple scopes set up, so if you have technical questions, let us know. And I'm going to pull up. Hi, Aaron. Thanks for coming out. We have a couple. Any questions that you want to address in chat? I don't have the stream pulled up. Shame on me.
Nothing's come in yet. We'll give everybody.
Okay, so we'll give everyone a minute.
Yeah.
So man, that snow day was something else, right?
Yeah, it was pretty crazy.
Yeah, the freeways were shut down, and yeah, if you missed yesterday's video, basically, can someone ping me a link to the live stream? I don't have it pulled up. Basically, yesterday we got hit with last 2 days we got hit with a blizzard. Everything was shut down. It was nuts.
Yeah, and I'm from upstate New York, and that was still one of the craziest storms I've ever seen. It was nuts.
Yeah.
All right, I just pinged that to you.
Awesome. Thank you, Aaron. And Mel's here too. Hi, Mel.
Okay. You guys have the oscilloscope shirts.
Do we have the oscilloscope shirt, the one that you wore last time?
Yeah, I think so.
We don't. We've thought a lot about doing a Teespring store. We're trying to figure out what to do. We don't really want to make money off of that, but we want to give you guys an opportunity to rock the Keysight swag. So we're thinking right now, tentatively, we'll try and put that towards like the Society of Women Engineers or a local makerspace. So those are coming. If you stick around on the Keysight channel, then you see those. We also get questions about the mugs, so we want to put together a couple mugs as well. Let's see. Who else is here? I'm not going to read that comment out loud. Yeah, it's been one of the biggest years we've ever had for Wave and Scope. So again, thank you all for coming out. Someone wants to know why you blocked out your computer logo. We're not really supposed to show other logos without like getting express written permission, but sometimes things just happen. So, so we got the gaff tape over that. Someone says all your entries were a waste. Your entries were not a waste because hopefully you learned a lot during Wave this year. Here's a question. Scope protection. Dave does a great video on how to not blow up your oscilloscope. One of the biggest things is don't connect different grounds up together because that'll do weird things. And if you're working with sensitive electronics and stuff, don't just reach in and go touching stuff because things will get zapped. So you can ground yourself on the BNC before connecting to a probe or your board. You can also do the anti-static wrist ESD straps and that type of thing. I saw a couple questions for you come in.
Yeah, someone said, Aaron, do you see that scope to your right? I want it. So this is the 3000T. Daniel was doing the segmented memory on it earlier, but I don't think we've talked about that one as much during Wave this year. But this is one of the touchscreen oscilloscopes. It has a little bit more capabilities than you'll find in the 1000X series, such as the touchscreen. Zone triggering, that kind of stuff makes it a lot easier to trigger and isolate things on your, in your signal on the scope. So yeah, check those out.
Yeah, someone asked, what if I want to measure the charge of a capacitor as low as 1 picocoulomb? Can you do it with an oscilloscope? Oscilloscopes aren't really the best tools for measuring capacitors and inductors and even like impedance of anything, except for maybe if you're doing a filter and you're using like the Bode plot capability in the Infinivision scopes. We recommend using something like an LCR meter for that. You can, however, measure the time constant of a circuit. We did a video about that I don't know, maybe 6 months ago, something like that. If you search like time constant in our channels, we talk about how you can basically measure the rise time of an edge. And then you get like the RC network, but there's a lot of variables in there, so it's much better to use something like an LCR meter. If you're on a tight budget, there's these like $5 or $10 meters on eBay. It's like a little LCR meter circuit. I think Dave actually did a teardown a while back, or a mailbag with one of those. But look them up on eBay. If you don't want to get like a full professional level LCR meter, you can check out, there's a lot of cool little options out there. I think they even do like transistor testing and that type of thing too.
Cool.
Yeah.
Someone else asked what my favorite signal integrity tips are, and I'm gonna bundle that with another question that came in about what matters more, sampling rate or ADC bits. So for signal integrity, there's going to be a whole signal integrity series coming out, a video series coming out soon, and also an ebook that kind of highlights some of the different important things you should be looking at, like ADC bits versus ENOB, the effective number of bits that are actually being used to make your measurements with the whole measurement system. That's going to really determine the accuracy that you're going to be able to see. And then things like ADC interleaving and what that might mean for your sample rate. So going to that sample rate versus ADC bits question, most people will look at ADC bits as more important. That's definitely one of the most important specifications. Same with ENOB, I would say that's just as important as ADC bits because that really tells you a lot about the entire measurement system. Sampling rate's definitely as important, but I'd say those first two, ADC and ENOB, are the most important specifications. But you have to remember, you have to look at everything in the measurement system to be able to get the measurements that you need.
Awesome. Great answer. Someone asked why aren't the scopes grounds isolated from the earth ground? We'd have to go talk with like an R&D person on that, but essentially the goal of anything is to get a very common ground. So earth ground is the best ground around. So when you're going to measure devices, you don't want to make floating measurements. You want all of your measurements to be arguably tied to earth ground. So that's why all the scope channels are tied to earth ground, but if you want to make floating measurements, you can use a differential probe. You can measure the ground and a signal. You don't have to measure differential signals with a differential probe. You can measure single-ended signals. You can also, differential probes are really the way to go if you're concerned about that. There's also some handheld oscilloscope options out there, or you could even use something like a DMM to make more floating measurements. So that's why scopes ground are connected. Someone asked, what is the fastest probe that we have? Does anyone know that?
I just did a quick search.
30-ish?
It looks like 30 what?
I
It looks
think we go
like
up to
3.
No, we definitely go higher than anyone know? 25 gigahertz. That's the Infinimax probe. Do you know the model number? Boone is off screen here. Boone is the guy you want to get an email from if you've won because he's the one handling. He did all the like less glamorous work of getting the terms and conditions worked out and all that fun stuff. There's the 25 gigahertz probe. Once you get higher than that, you start to look at like direct connecting and that type of thing. So yeah, it's a darn fast probe. What else? So why aren't differential probes standard? It all comes down to cost. We would make everything standard if we could. But honestly, when people are going to buy a scope, they don't want to necessarily pay for all the development of all the possible options like differential probes and current probes and power rail probes, and there's just so many options out there that it's best for everybody to kind of have the probe that works best for them, and then it's not subsidized by other people who don't need it at all. So that's kind of why that happens. Do RF, ASIC, et cetera engineers design their own products using ATS Momentum or a different software? We do use ADS actually. On the podcast that we did Wednesday, we had one of the packaging engineers come out and talk. Jesse talked a lot about it, and they use ADS to look for like crosstalk and all kinds of different simulations they run on their packages before they actually ship it out to production. So we use a ton of different software tools in here. Our R&D teams use all kinds of things.
Someone asked what the highest voltage you can measure with a probe. Looks like we have a high voltage differential probe that goes up to 7 kilovolts.
7 kilovolts is a lot.
Yes.
So don't go playing around with 7 kV.
Yeah.
There's a lot of safety concerns when you get that high up, so obviously you want to know what you're doing. We do see pretty commonly like hundreds or thousands of volts for like gallium arsenide switching. So you need a really fast edge rate, but because it's really fast and really high voltage, just the way those processes work. We actually did a podcast on that too. It's like a podcast plug day apparently. But the gallium arsenide switching has some unique challenges with probing. So what's the slowest probe that you have? I think I can answer this one. The switchable 10-to-1, 1-to-1. 1-to-1 probes, when you switch down to 1-to-1, you actually tank the bandwidth to a few megahertz, and that's intentional. Usually when you're going 1-to-1, you don't care so much about getting that high bandwidth. You're really looking for a good signal-to-noise ratio. So as you start to get to those more sensitive, 1-to-1 type attenuation ratio probes, you get lower. I think it's like 6 or 8 megahertz. That's pretty standard for 1-to-1 probes. What else?
Somebody said I want it to work like a DMM, so it's a good opportunity for me to mention that they do have built-in standard DVMs, digital voltage meters, as well as a frequency counter. The ground is still grounded for that, though. So if you're looking for that floating DMM measurement, use a DMM or a differential probe. Yeah. Is there a 9.5-digit multimeter in the future? I'm sure there are some serious physical limitations with that, but I imagine it's possible. We'll have to pull John Kenny out and do a couple videos with him. He's kind of our resident power DMM guru, been doing it forever. Dave Jones also interviewed him for a couple episodes. You can check those out. Those are great conversations. Someone asked, are the winners real? Yes, the winners are real. There's some forum posts around of people doing unboxings and stuff like that, so you can go find those from previous years. Yeah, it's real. If it wasn't real, we'd be in big legal trouble. So we're definitely giving away gear. It's also kind of our way of saying thank you to you for being, fans of Keysight. Which scope would you recommend for an advanced hobbyist, Aaron? Advanced hobbyist. So the 1000X series is definitely good, especially for the price and what you're getting. But if you're looking for something a little bit more advanced than that, the 3000T is a good next step. The touch screen's really nice. Having the option to do the digital channels is great for any embedded designs you're doing. So yeah, I'd suggest the 3000T or the 1000X.
Yeah. There's also a couple comments about how to kind of do use the right word, a differential probe with 2 passive probes, and you can basically take the difference between the two. That's another way of doing it if you're on a really tight budget. With passive probes, you should use matched probes, and there's a couple other considerations. I think we maybe covered that in how to measure current with an oscilloscope. So that is an option out there, but it's really just not, it's worlds worse than using an actual differential probe. So if a differential probe is something you need to use regularly, you should get one, or rent one, or do whatever you need to do. Let's see, what else? Okay, someone's saying you need more than 32-bit ADC to get a 10-digit DMM, and with like 0.001 ppm voltage source. That's like 1 part per billion. So yeah, honestly, once you're at, I think we go up to 8.5 digits or 8 digits. Once you're that high up, you don't have to necessarily get that specific if you're looking at. You don't need to go look at picovolts that's writing on 1 volt signal. It's not really something that people generally need to do at this point in technology, but in the future, you never know.
Somebody else asked what the highest voltage the scope can measure. So it looks like the highest voltage that well, it definitely depends on what scope you're looking at. But for the 3000T, it looks like the highest was 190 volts peak to peak. So yeah, depends on the scope. A couple of them might end up going higher than that, I'm not sure.
Yeah. So we're almost out. Sorry, it's too late now to enter the draw. The event is over, sorry. So we're gonna wrap up. So put any last questions in the comments. Any tips for probing signals on a close FPGA chip without using a breakout board? There are a ton of probe accessories out there to get really tight into some of those pins that are coming right out of the chip packaging. So I think there's some tips around that on our website. And go look at the probing accessories. There are options out there. There's some tip adapters and stuff like that. We also, if you're working with, you know ahead of time that you're going to need to probe some signals, building in a couple probing points in your board never hurts, especially if you have a little bit of overhead as far as signal fidelity goes.
Yeah. Someone else asked about measuring currents down in the microamp range on an oscilloscope. You can use the N2820A. Those are the high sensitivity current probes. We talked about them a few days ago, but those are the ones that you have the option to have 2 channels, so you can look at the higher voltages in the amp range and the lower voltages in I think it goes down nano amp range. But then there's also the N7026A. That's a high sensitivity clamp on current probe. And that goes down to 1 milliamp per division. So I guess not quite as much sensitivity as that specific question, but definitely check both of those out. Awesome.
Okay, we're going to take one last question and then call it a day. Someone asked, what is the widest bandwidth spectrum analyzer you have, or signal analyzer? If you go over to the website, I think someone might be looking it up over there. I don't know. Mel's making a face, so maybe not. We go pretty wide and pretty high bandwidths, but what we're seeing with 5G and some of these new emerging millimeter wave technologies is that signal analyzers are really becoming more and more difficult to use, especially as scopes start to integrate digital down converters. We were going to have a podcast this week about how to use scopes in an RF environment to get super wide bandwidth measurements, but the snow held up a couple people. So someone says 120 gigahertz. I don't think that is true. That's not true for anything. Not for RF. If you're trying to measure narrow bandwidth stuff, a signal analyzer, you just simply cannot beat it. The noise floor is great. You have great dynamic range. If you need to measure gigahertz and gigahertz of bandwidth, it's time to maybe start exploring other options. So you can check out our signal analyzers over on the Keysight.com webpage. We also have, how many? Oh, you did? 1 gigahertz. Okay, of analysis bandwidth. Awesome. So 1 gigahertz, and that's a ton for a signal analyzer. That's just crazy. Because what bands are you looking at that are gigahertz wide? When you're communicating, usually it's it's single megahertz or double-digit megahertz at the most, depending on the technology. So thank you so much for watching. We're not going anywhere. We're just ending the live stream and Wave is over. But like I said, we're around. So subscribe to the Keysight Labs YouTube channel. Check us out on Facebook, Twitter. Check out the podcast.
Don't forget to check out my signal integrity video series as well.
Yes, Arent has a new signal integrity video series coming out. We've seen some of the pre-roll for that. I'm really excited for it, and Arent did a great job with it. So look for that coming up soon on the Keysight Labs YouTube channel. I'm Daniel Bogdanoff, and Aaron, thanks for coming out for QA.
Thanks.
And we will talk to you and see you later.